Hi friends, very good evening. I'm back with the second video in continuation with the previous demo video on basic syntaxes of Arduino. So here in this presentation I'll be talking about how to interface an LED with Arduino. Okay. So when you consider the GPIO block of this Arduino, you will be having GPIO is nothing but general purpose input and output lines. Okay. So you will be having an input and output, an input peripheral and output peripherals. All the peripherals of Arduino are bidirectional. It means that you can interface either an input peripheral or an output peripheral. Okay. And that peripherals can be either analog or digital. Okay. When you are interfacing an analog peripheral, you need to connect at analog AV lines. If you are interfacing a digital peripheral, you need to connect at digital AV lines. Okay. So when you talk about reading and writing, okay, when it is input, you can read the data from the input peripheral, but you can't write the data into the input peripheral, right? When you are interfacing an output peripheral, you always write some data into the output peripheral, but you can't read the data from the output peripheral. Here, input action is required. Read action is required when you interface an input peripheral. Write action is required when you interface an output peripheral. Clear? So here, since I am interfacing an LED to the Arduino, okay, to which pin I need to interface? To any digital IO line, I need to interface this LED, because LED is simple digital. Okay. So since it is output peripheral, I always do some write operation here. I can't perform read operation since it is output peripheral. What is a connected peripheral here? Yes, I am connecting an LED. Obviously it is digital. It is digital. What is the status of this peripheral? It is output, because LED is always an output device. So number of arguments are 2 here. One is pin, second one is data. Okay. First one is pin, second one is data. To which pin I need to write? Okay, and what I need to write. Since it is digital, I can write either 1 or 0. In Arduino, 1 is indicated with high and 0 is indicated with low. Okay, so digital write is a function, is an inbuilt function where you will be having 2 number of arguments and no return variables, and there are no return variables. Okay, so first argument is nothing but to which pin I need to write, and second argument is nothing but data, what I need to write, either high or low. Okay, so here let us consider this circuit. Okay, I am having an LED, and this LED is connected to pin number 13. So it is connected to pin number 13, which LED is a semiconductor diode. Okay, LED will emit light in forward bias condition. Okay, when you see this LED, okay, this is anode terminal and this is cathode terminal. This is anode terminal and this is cathode terminal. Cathode terminal is connected to ground. Okay, cathode is connected to ground. Anode is connected to resistor, and the other end of the resistor is connected to pin number 13. Okay, and this is my circuit where interfacing an LED with Arduino. Okay, anode is connected to resistor, the other end of the resistor is connected to Arduino, and cathode is connected to ground. If you want to make this LED high, or if you want to make this LED on, what logic I need to assign here? While assigning logic, you need to keep this point in mind. What is that point? This fellow will emit light only in forward bias condition. When you go for forward bias condition, anode voltage should be greater than cathode voltage. Here cathode is connected to ground. Obviously you will be having only one option, that is nothing but high. Since cathode is low, anode should be high. Then only this fellow will be in forward bias condition. That is the logic. Okay, understood. When Arduino pin is high, obviously that is what I am saying. When Arduino pin is high, LED will be on. When this pin number 13 is high, then this LED will be on. Then high logic will be assigned to anode and low logic will be assigned to cathode. Obviously anode voltage will be greater than cathode voltage, then LED will be on. If you want to make LED off, then what you need to do here? You need to maintain low at pin number 13. Okay, I will be having two types of programs here. One is glowing an LED and second one is blinking an LED or toggling an LED. Okay, so here my target is I need to interface LED cathode to pin number 2. Okay, what is happening here? I need to interface LED cathode to pin number 2. It means that anode is connected to VCC. Okay, it means that anode is connected to VCC. So let's do this in practicals. Okay, then you will understand what is happening here. Okay, so to program this target I need an Arduino software. Okay, this is my Arduino IDE. Okay, this is my Arduino IDE. So every Arduino program will be having two loops. One is wide setup, second one is wide loop, and these are the fundamental functions in Arduino. Okay, so here as per the presentation, see, interface LED cathode to pin number 2. Okay, it is very clear. I am interfacing an LED cathode here. So to which function I need to call here? So I need to call a function called pin mode. To which pin it is connected? It is connected to pin number 2. What it is? It is output, because it is LED. Okay, so if you want to make LED on, it is very simple. Here LED cathode is connected to pin number 2. Okay, it means that anode is connected to VCC. If you maintain low, then this LED will be on. Okay, so what function I need to call? digitalWrite. To which pin I need to assign? Since LED is connected to pin number 2, I need to assign it pin number 2 only. Okay, what I need to assign to make LED on? Obviously low, because anode is connected to VCC as per the given target. Okay, if you want to toggle an LED, toggling an LED is nothing but making LED on and off for for infinite number of times. Okay, so if you want to see the output, I need to maintain some delay. Okay, delay is also a predefined function in Arduino. When you write delay of 10, it means that this LED will be on for 10 milliseconds. Okay, it means that delay is nothing but delay of 10 milliseconds. After 10 milliseconds, I need to switch off this LED. So what logic I need to assign? 2, high, which is nothing but LED off. After this, I need to maintain some delay, so in order to observe the output. Okay, so you need to save this. So Control S is the command, or you can go for file and save. Okay, you need to save this program. Okay, I am giving it as demo. Okay, save. No extensions are required here. Just write the name and click on save. Okay, your program will be saved. Okay, I am using Arduino simulator. Okay, in order to show the output. Okay, to simulate this program, I am using Arduino simulator, which is an open source. You can download from internet. Okay, first you need to load this file. This is my demo file which we have written, and you need to click on open. So this is my Arduino. Okay, how many data lines will be, how many digital lines will be having here? It is D0 to D13. How many number of analog lines will be having here? It is A0 to A5. Okay, and in setup I have written pin mode. In loop I have written like some statements here. Okay, I need to click on play or run. Okay, what is happening here? See here, which is not. So here LED is connected to pin number 2, so that is why it is toggling here. The program, the logic written inside loop is nothing but making your LED toggle. So here you will be seeing some red symbol is toggling here. That's it. All about digitalWrite, and this is how you need to interface your LED. Thanks for watching our video. I'll be back with another video here, and this is Madhu signing out from Arduino e-course. Thank you.